This is a demonstration of equilibrium where we're going to shift from hot to cold, cold to hot. Cobalt chloride is sold as the hexahydrate, and you recognize it as pink solid. This pink solid, if dissolved in water, remains a pink solution. The ion that gives the pink color is called hexaaquo cobalt 2. Hexa for 6, aqua for water, and cobalt 2 has a charge of 2. If you dissolve it in an alcohol, such as methanol, ethanol, or isopropyl alcohol, isopropanol, 2-propanol, you end up with a blue solution. And what happens is the water is displaced and chloride ions surround the cobalt ion, and it becomes tetrachloral, 4 chlorines, all -1 around the cobalt ion. So tetrachloral cobaltate, because the charge is -2, 2. And what we are going to do is get a color in between these two in a third test tube, and by taking a little bit of the cobalt chloride, pouring in isopropyl alcohol, and dissolving it up. Now, if we very carefully add some water to this, it will.
Mr. Hewitt, call 1181. Mr. Hewitt, 1181.
We can adjust the color. So that it's not blue, it's not the pink. It's a purplish color. Just a couple more drops. It's very, very sensitive. See, the water is denser than the isopropanol, so it goes pink at the bottom. I think we're in between there. And so we have hot water here and cold water here. If I put it in the cold water and let it sit, you can see that it's pinking up. Why would it go pink? Well, the stress on the system is to make it cold, so it wants to do the opposite. It wants to heat up. And in heating up, it would have to form more bonds. So by forming 6 instead of 4 bonds, that is bonding the cobalt ion bonding to 6 waters instead of being bound to 4 chlorine, it will turn pink. Now, if we heat it up, it stresses that we're heating it. What does it want to do? It wants to cool itself down. So it's going to form fewer bonds. To do that, get rid of 6 bonds to water and pick up only 4 bonds to the chlorine, and it's going to change to blue. So we have an equilibrium shift just due to the temperature.